Well, hi, good morning. We're coming to you live from the Mint studio. I am Alisha Sachdev, and I'm privileged to be joined by a very authoritative panel of auto OEM veterans, policy makers, and startups who are doing important work in the EV ecosystem. Now, we are holding this conversation in the backdrop of multiple instances of electric two-wheelers catching fire over the past week, particularly those involving an Ola, S1 Pro in Pune and an Okinawa scooter in Tamil Nadu, which in fact claimed two lives as well. Now, this was an incident, of course, of what the company said was a case of negligent charging, but there are fundamental issues perhaps here as well. The worrying bit is that these instances are growing. There were about half a dozen reported instances of such fires last year, and this year so far, we have already crossed that number. Now, as the pace of EV adoption also grows at the pace that it is, what are the safeguards we need to build at the OEM, regulatory, and customer level to ensure that this nascent industry does not overlook quality and safety as it grows? So thank you very, very much, gentlemen, for joining me on this panel today. And let me start with you, Rakesh, sir. At Bajaj Auto, you are a leading two-wheeler OEM with a well-accepted Chetak EV on the roads right now. But of course, so far you've been doing smaller volumes. As you expand production now, given your strong R&D backing and the reputation you have as a brand, how do you think about maintaining the integrity of your EVs when it comes to safety? What are the imperatives that you are keeping in mind as an OEM, and what do you think needs to be ensured at an ecosystem level to see to it that we do not see these occurrences happen again?
Thanks for having us on this show, Alisha. There is no doubt that this is a wonderful new technology, the movement to lithium ion, and it is opening up a world of possibilities, and it is a genuine advancement, which is very, very beneficial on many different dimensions. But having said that, it is certainly new tech as far as mobility is concerned, and that has to be understood. So we have to look at it with the lens which we apply to all new tech, which has to be integrated in our businesses. So I would sort of say there are three important things which one needs to keep in mind as we are using this new tech and presenting new solutions for mobility to the consumers. The first in Bajaj Auto is around responsible design. A lot of it is got to do with energy management and the consequential heat management. This is a very different ballgame from the ICE system. Lithium ion is very dense, and now when you are supplying energy to the cells, which is charging, or you are taking out energy from the cells, which is the use, there is a lot of heat which is generated, and therefore there is heat transfer, the heat dissipation management. And now all that happens with responsible design. If both the energy management and heat management are well balanced, where design doesn't fall into the temptation of trying to extract a much higher performance, where the overall design does not support that, even if it is momentarily, then issues can occur. So I would say responsible design, both in terms of setting the performance standards, in terms of managing energy and managing heat through the various methods. And there are various protocols, battery management software, the physical design of the packs and the cooling and all that. The second principle would be sourcing new vendors. These are a lot of these components are new, and there are new vendors on the horizon. We all know the issues with supply chain. It is very important to not fall into the temptation of just for convenience or for price to go to untested vendors, and so you have to buy all these products from certified, well-established vendors. That is what our attempt has been. And even if, and a lot of times what happens is when you go to these people, there are delays, and there are cost disadvantages. But in the end, it is very important for us to go to these established vendors, so that we get good quality stuff.
Hmm.
And then, of course, there is the third principle is, testing and validation. There are multiple use cases. A lot of times we have had the product, but it takes a long time to validate it in the field, so that all the use cases have been experienced by the product. When in 2019 we did a 3,000-kilometer journey on 21 Chetaks, it was not so much for publicity, but it was more for understanding what all an electric
Hmm.
scooter could be put through, and it was very valuable information. And finally, I would say that we cannot play the importance of customer education and service. I'm
Yeah.
not saying that we have to demand the customer to behave in a certain way. There are these use cases which, and a responsible OE should service the 99% of the use cases, not the abuse cases, because we can't keep telling the customer, park it in a shadow and
Yeah.
do this or do that. That's all wrong. So our product has to be robust enough. However, having said
Sure.
that, I think some bit of customer education and responsible charging, the importance of service, the where the wear and tear is looked at, where the connectors and all that are serviced once in a while. These things are important. So I would sort of, to the first three principles of
Hmm.
design, good sourcing, testing and validation, I would add, taking it forward and sort of some bit of customer education and having a good service backup which the customers can easily access will be very important. So for the industry to leverage this wonderful advancement into lithium ion.
Right, sir. I mean, that's a very comprehensive sort of a framework that you've laid down, with which to actually look at this, problem. If I can go across to Suhas now, you heard from Rakesh, sir, he was mentioning that there are things that you cannot, sort of short circuit. There are processes like testing and validation to ensure that your sourcing, happens from the very, the most reputed vendors. And of course, solving for these issues, preempting them at the design stage itself. With the product coming up now, and you are, one in a sort of a race, if I may, to actually capture this EV market, one of quite a number of startups who have a product coming up now. How do you ensure that to minimize sort of your lead times, your delivery timelines, you do not end up overlooking these processes?
First of all, thank you, Alisha, for having me here and giving an opportunity to speak about the most important aspects of EVs, that is battery safety. I think again, a supply chain is secondary, or any other point of things are secondary. The first and foremost thing that any company or any EV startup, or someone who wants to develop an EV should focus on is the battery component and the powertrain components, right? So when we look at developing certain things, you need to first map the country or the continent, or the location that you're servicing it to be. You
Hmm.
cannot apply the same methodology of every other country and replicate here by the
Yeah.
standards of yours. So you'll have to really put in some work to work on the data points to understand what are the temperature variations, what are the external factors that affect the EV scooter end of the day, right? And what are the conditions the average consumer would be looking at. It can be the lowest of the size or the extreme end of things, right? So when we start designing, we also need to look at what are the infrastructure that is currently available and what is not available. Again, a designing factor comes in three stages. One is, of course, where you just pack and test it out and try and understand the inputs on it. Second is, of course, how you are gonna make it for an average end user. And third is, what are the missing points into the design element itself, right? For us, it's simple one. We've designed our own PCM material, understanding the current temperatures, average use case, and of course, heat dissipation methodologies that we apply, and try to map it out. We have designed it accordingly, that, and that is important at the core of it. It avoids any circumstances that might come up. Apart from that, the dealer point, or sorry, a supplier point of view, of course,
Hmm.
reputed cell manufacturers everywhere, but fires can cause not only by bad design but
Sure.
also by bad cells, right? So a lot of
Hmm.
suppliers tend to neglect the factor that the quality checks on the cells need to be precisely there, because once we receive it at our end, we sometimes miss out the quality checks. That is proved to happen because your cell sorting machines are not so accurate enough as of now that can predict what are the factors that are coming in, whether the cell is degraded, not degraded, how well it is being stored, and things like that. So all these factors do come in, and we cannot just neglect that part as well. So it has to work hand in hand for everything to fall together and deliver a quality product.
Right. And all of this you have to, do now, particularly in the backdrop of, like I said, there is competition that catches up with you, right? So, what seems to be playing out right now is also the conundrum that do we just refine the product as we go, at least ship it out, because there is that much demand, or then do we take our time, and again at the cost of, offending, Mr. Sharma here, Legacy Auto has been doing this, right? Taking their time and really perfecting the product, before you put it out into the world. So where do you stand on on this, Suhas?
See, taking time out is always better. Without data, you cannot start designing. So we are always in favor of take time out, build a quality product, and once you put it out, it should not go back to the factory for any kind of complaints, anything like that. So that is our stake, and we've been saying this. R&D takes time. Hardware is tough. It has a lot of vertical integrations and quality checks on each vertical, right? It cannot be just assembly and cell model. It has to be R&D, assemble and sell model rather than anything else. And it takes some time. It takes 24 to 36 months for a product to mature enough. And I look out for that. We started in 2019. We have been still working on it. We developed our PCM in 7 phases over the last 2.5 years. So it's not an easy task. It's definitely gonna require some time, and it is important because end of the day, it's customer's life, and the product that you want to build and a brand you want to cater for next 100 years at least.
It's encouraging to hear that from you, and I really look forward to the Simple One launching then, and I hope that it incorporates all of the things that you mentioned.
Absolutely.
Randheer, coming to you now. Customer education is, of course, one key aspect to this, but automakers cannot always bank on the customer making the wise decision, right? Of always following instructions, sticking to the use cases that, do not sort of put them in trouble. There is a set of regulations, which is the AIS 156 safety standards, for, EVs, batteries. But they are not made mandatory on all OEMs so far. They are, a fairly, advanced and strict set of standards, whether it's, mechanical shocks, mechanical abuse, or electrical abuse that the batteries are tested for. Um, what do you think needs to be done so that it can be impressed upon manufacturers also that these standards are important to follow, and how can the regulatory authorities ensure that this is in fact followed and followed through, not just at the certification stage, but consistently during production also?
Thanks, Alisha. So, Alisha, before I delve deep into about the standards, let us first take a time and understand why do batteries catch a fire. Of
Sure.
course, a lot has been spoken, but it is important to understand why lithium-ion batteries catch fire in the first place. Today, lithium-ion batteries are all around us. They are smartphones, consumer electronics, laptops, power banks, in fact, the tablets.
Yeah.
But those which are used in EVs, these are different from the rest. Number one, they store up to 3 times more energy than laptops or any other household appliance.
Hmm.
Plus, the abuse they have to endure is also totally different, and their exposure to wide temperatures, dust, humidity, vibration, water, in fact, and high rates of charge and discharge, because
Right.
they have to meet a different performance conditions. So, for example, to increase a vehicle's driving rate, it requires high capacity. It means the long strings of the cells, high energy storage, plus a BMS malfunctioning in these conditions or inadequacy of BMS. This can lead to such cases. So talking in terms of the EVs, the powertrain itself is actually very, very simple. Everything is there in the battery. So in most of the cases, it's either the battery or the high voltage power electronic and the high voltage cabling which is there to connect to different parts. So the malfunctioning could be triggered even by the one faulty cell. So most of the cell are right now being imported. So there should be more stringent tests on the batteries. That is for sure. But the thirst towards self-assessment, This is something which has to be made, and industry needs to act responsibly. Last year, 156 was released, which is, as you know, is one of the most stringent in the world. In fact, it is better than UNR 136 and UL 2272 as far as the testing of the batteries is concerned. But to comply with this regulation, in fact, the vehicle has to undergo variety of tests. As you already said, vibration, thermal shock, short
Hmm.
circuit, mechanical drop test, in fact, overcharge, temperature and discharge, mechanical shock. But on top of all these, the most rigorous of them is the fire resistant test, where the battery is subject to a direct and indirect flame for over 2 minutes. In fact, this condition is not there even in UL 2272 and UNR
Yeah.
136. Plus, for 156, by December 2022, everyone has to shift to this standard. This is also mandatory. In fact, we also have an update that now whomsoever is coming for the testing of their cell, nobody is adopting or even asking for the 048. Everybody is going as per the AIS 156 only. So, there are multiple factors which can cause the battery to malfunction. So also the looking at the volume of the lithium cells which are being imported, it is important that each cell should be individually checked at the battery manufacturer level, and only
Hmm.
those that meets the norms and the quality standards should make the cut. Because even one bad cell, it can lead to a safety hazard or a malfunctioning of the entire battery pack. So there is an increased need for the self regulation, I must say this. There could be, for the self failure, there could be multiple reasons: short circuit, gassing, impedance growth, further internal and external issues. But then finally, compliance with the standard and the self regulation, both of these things together has to be acted upon.
Right. Mr. Gill, welcome, to the live conversation, first of all. Mr. Sharma was talking of Bajaj Auto, was talking about how there are three levels to ensuring that, you are building a robust and safe EV. He mentioned sourcing from reputed vendors. He mentioned testing and validation. And he mentioned that, we solve for these problems at the design stage itself. Hero Electric has been, in the EV two-wheeler business for over a decade. You are the largest player in the market currently. Of course, you have been selling predominantly, for a while in the low-speed category. So perhaps, you were able to favor safer chemistries. But does it concern you as an OEM with a number of EVs on the roads, the recent instances, that we have been seeing? And I mean, how do your interactions with customers also go at this point? Where they could be starting to get wary of buying EVs altogether now that these instances have started to service as much as they have.
Yeah, Alisha, thanks. Yes, surely we have been having some sleepless nights lately because of this eruption of not only one, two, but many incidents, and it can happen to anyone. Now, everybody is working, and this need not be a technical session of trying to explain because audience largely won't understand what we are saying from better
Sure.
BMSs, better these things. But I would go a little back on there are millions of batteries already in the field. Can we do something about it? Because any of them can catch fire and threaten life and property. Then work back
Correct.
onto other aspects of making it from the root cause in the future. So there are checks and balances which are still possible to be done on the existing batteries in the field because any of them, any one in the million cell can misbehave and catch fire. So the consultation should be that now onwards in the next 1, 2, 3 months, let's not see to it that even if it catches fire, it is not damaging enough, it is not so much explosive enough. From that point of view, like we have been working very closely with a Canadian startup, and we are going to implement very soon a 3-stage alarm on the top of the battery, which can be fixed on any battery. I would request everybody to start using it, perhaps in the category level also. It's a simple alarm, which is like a panic alarm, which women use in case of anybody tries to do, like it's a button cell alarm, and it has a thermal sensor on it. And this alarm is pasted on top of the battery, any battery, nearest to the terminals where the heat gets captured. So what happens? As soon as the heat crosses, the temperature crosses a certain threshold, 100, it says caution. It starts blubbing, up, 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 caution. Second level, now it has become unsafe, another high pitched sound. Third level, it is dangerous. It's constantly making shrieks noise. And for some of us, we are going to Wi-Fi connected to your phones also. So after some time, if it is possible, we would like to put it retrospectively into the existing batteries also. At least batteries in the field will have some sort of a safety quotient, not from a design point of view, but from a containment of a life and property point of view. So this is a one step that everybody should think. It is a very simple device. I would throw it open for anybody who wants a design from us. Second thing is, again, the best of the cars have had fires. The best of things have had fire. But what have they learned out of it? Let's learn from them. Second thing that is to be learned is, how do you contain when the fire starts within a battery? We have been checking batteries at SMEV level from many of the vehicles in the competition. Almost all of them are totally sealed like bomb. In fact, they feel that stronger the steel jacket, better it is for the battery safety. It is opposite of that. The stronger you make it, the more the bombing effect you will have when it explodes, because gases cannot be contained after they are exploding. So one has to release those gases in case of a mishap. Now today, if you are releasing it, you're releasing only from the cell level, not from the battery level. So the next thing that perhaps should be done, and we are at least going to do, is partition the batteries into 2 and 3 partitions, not one big box. And each partition would have a release valve, so that small partitioned compartment only catches fire, not the whole battery. And that too doesn't become a bomb. It releases the excess pressure into atmosphere. Basic things, very basic things. But let's work back from what is in the field as lying as explosive, then work back into the battery designs, then work back into sourcing, and then also many things like customer education. So this is the time to, in fact, share this information, share this knowledge for everybody's use, and take it as a collective, not my battery versus your battery.
Right. Good to hear that from you, sir, that you're addressing this so proactively. Arun, we have been speaking about batteries, in this conversation. You are building a fast charging solution for lithium ion cells. The expertise, if I understand Exponent Energy correctly, would be the battery management system that you will, be able to provide to, the OEMs that you work with. Speak to me, what your understanding is, in terms of where the current problems seem to be coming from, and how do you address that? As a player in the ecosystem, what would it take a better battery BMS? I mean, a better BMS. I mean, just your assessment of these incidents that we have been seeing.
Thanks, Alisha. Thanks for having me today. Wonderful to be here. And I think good question. And there's a lot of misconception around why batteries catch fire or why EVs catch fire. Right? At the top level, let's break it down into 2 categories. One can be an electrical fire, which is, hey, I plugged the EV into a wrong socket, into a badly designed socket. And this is a common occurrence that can happen for any electrical appliance. It could be a geyser, it could be an EV, etc., right? But I'm going to keep point 1 aside and focus on point 2, which is the battery catching fire, right? And the general misconception there is, hey, it's summer, it's hot, thermal management is the reason why batteries catch fire. That's actually not true, right? If I were to break down this whole performance into 3 metrics, right? One is performance, the other is life, and the third is safety, right? Bad thermal management, if not extracting the heat out, affects 1 and 2. It affects performance and life of the battery. So is my vehicle switching off? Is my vehicle able to give me top speed for enough time? Is there a premature degradation? It's like your cell phones, right? If you leave it in the dashboard, you've probably seen your cell phone slow down, and that's because it's heating up. And it also leads to definitely shorter life of the battery if it's hot, right? But this is not the big concern, right? The big concern today is the third, which is safety. And 99% of the time, a fire catches, and a battery sort of catches fire because of short circuit, right? And this can be an internal short circuit or an external short circuit, right? If you look at a cell, it's basically got 2 things. It's got a cathode and an anode, right? The positive and the negative. Now, when we are discharging, what we're basically doing is we're connecting them up in a controlled fashion. We're ensuring we connect them up through a motor, and we're able to control how much current we're able to draw out of the cell. But what happens if both of them touch accidentally, right? That's when you have uncontrolled currents, and the temperature goes beyond a few hundred degrees Celsius. right? Now you can't actually heat a battery up to a few hundred degrees Celsius by leaving it out in the sun, right? It just won't happen, right? So all the things that, hey, summer is here, that's why batteries are catching fire, etc. That's actually not true. Yes, heat is bad, it affects your life and performance, but that's not the reason batteries are catching up fire, right? It's because of three things. A, you've bought a bad cell, or B, you've designed the battery really badly, specifically on how you've connected these cells up and how you've held the battery or how you've held the cells. And three, you've got a really bad BMS or no BMS. So you're managing the cells on a daily basis really poorly, right? So this leads to a couple of things. It leads to something called a dendrite formation that happens inside the cell, which can then basically have something called internal cell short circuit, right? Or it could just be a simple problem that I bought the best cells, but I built them really badly. Like I just designed them really badly. It's going on Indian roads. They're all shaking up and they're all coming smash against each other, and it's called an external short circuit to a cell. Basically, It's happening inside the battery but outside the cell, right? So these are multiple reasons to why this happens. It's very easy to say, hey, it's a supply chain problem, we should buy better cells. But honestly, you can buy bad cells and you can catch it very easily when it comes to you. And you can also catch it preemptively. If you've got a good BMS, you've got good software, you can catch it, right? So 90% of the time, batteries catch fire because you're charging them, or you're charging them badly. You're charging them blindly, right? Most batteries today just have cells wrapped up in a blue shrink wrap with an analog BMS. They're built like batteries. You know, you've seen batteries for remote control cars, right? When we're younger and we play around. A lot of EV batteries are built that way, right? I'm not saying the specific batteries that caught fire were built that way. No specific input on that. But it's to me, it's very scary that you're carrying 2-3 kilowatts of cells put together in a shrink wrap manner, and they have basic, I would call them dumb BMSs. These are BMSs that are slightly smarter than an MCB. They just ensure if you have a short circuit, it trips of something, but they have no more intelligence than that to preemptively ensure that, hey, that cell is behaving badly, let's do something about it. None of them, right? And even if after all of this, you've got to ensure that you design the battery such that you don't have a runaway condition. You can have a single cell short circuit. The objective is to get it to 1 in million occurrence, right? And that's okay. But let's say a single cell does catch fire or does go into a short circuit, you cannot have a thermal runaway. So things like, do you have other material in the battery to absorb this? Do you have a cell-to-cell spacing sorted out? So these are things that you have to look into. So this is not a let's throw money at it, buy cells together problem statement. It's a deep tech problem. It's not a mechanical problem, which is why a lot of people are also approaching it slightly differently. It's a mechanical problem, 33%. It's an electronics problem, 33%. And it's a software problem, 33%. You can build software for apps and it can crash all the time. But if you have your BMS software, which is the primary job is to monitor cell and be like a watchdog, and it has to work 99.9% of the time. You can't have software crash. So these are all the reasons you got to do better. And at Ather, we put out 25,000 scooters, very high performance. Hopefully, I haven't seen an incident there. Hopefully, I won't see that soon. At Exponent, our focus is heavily on charging, and we believe it's our responsibility to ensure the batteries don't catch fire. So, with respect to BMS accuracy, with respect to software, how we write it, the sort of cell spacing, cells actually breathe, right? Cells are not like tin cans that just stay stiff. They actually breathe. So you got to allow cells to breathe. Imagine wrapping cells together really tightly and not allowing them to breathe. They will actually compress and explode, right? These are all the reasons. We actually have a video. We're going to post it sometime. How we actually on purpose explode batteries. And it takes a lot of effort because you have to switch off all our protections. You have to switch off, remove our BMS, and try really hard to explode batteries, right? So the fact that they're happening so easily out there.
Right. I think, probably it's been a good introduction between you and Randheer also, and a good precursor to the meeting that you are to have tomorrow. But good point there, Arun. So Randheer, there was a bit of technical speak there, but the fundamental point, as I understand Arun was making, was that the BMS and the, and the way that the battery, packs are made needs to get a lot more sophisticated. The recent instances that we saw, they were not fly-by-night operators. These are OEMs who have also been investing, and have, in the case of Okinawa, in the case of other brands, they've been in the market for some time. What do you think again? And customers at this point must be looking to the government to formulate or come up with some sort of guidelines to ensure that what they are buying will meet a certain specific or a threshold safety standard, right? That would instill confidence in them. And one of our readers on Twitter asked us, is it possible to have a standard testing agency, like a GN-CAP does, for ICE vehicles to ensure that the vehicle you're getting meets a certain level of robustness?
So, Alicia, I don't know why people are not aware that cells are being tested under BMS only. It is tested as per AIS, Automotive Industry Standards. It is being tested. Under the MORTH, there is a council, Automotive Industry Safety Council is there, AISC, which formulates the guidelines and the standards. So cells are already tested, and in fact, as I speak, I already told that AIS 156 is stringent in the world. It is better than 225, 272 also, and in fact 136. So the testing is being done at the with the most stringent of the conditions, as well as of course there is not a separate test for the BMS, but when these cells are being tested, it is along with the BMS it is being tested. Finally ARI also need to ensure that the facility is not getting busted into pieces, so they test along with this for sure. As I said, in India, the working conditions, discharging and the charging conditions, and as most of the cells are being imported as of now, each and every cell is not being tested by the battery assemblers. And that is, in fact, the need of almost everybody who spoke here. It's very clear that even a single fault in single cell can lead to the thermal runaway. And if it is not at the right time being detected by a proper BMS, then it leads to a big fire hazard. That is the biggest issue here. And this single thermal runaway can be even at the manufacturing stage. Even a single impurity in a single cell can lead to this type of thermal runaway. And if your BMS is not sufficient or adequate enough to detect that at the right point of time, this fire can happen. In fact, we have seen not only couple or few, there are hundreds of instances around the world which has happened. It only needs that the companies and the self-regulation and the self-assessment along with the standards and the codes, together only they will work for this consumer safety. And of course, what has happened with these three instances and couple of instances earlier also, this needs to be evaluated, investigated. And as most of you are aware, and I have also read that the committee is being constituted and independent experts are going to do this evaluation. So I think I will not comment much upon this. Let's see what comes out in particular to these instances. But definitely, I must point out something that looking at the actions which companies around the world has taken after the fire incidences in their vehicles, similar actions we must see, and the companies responsibly should act accordingly within India also. Thank you.
Right. Right. Thanks for that, Randheer. Mr. Gill, I want to turn to you again. You spoke about how you are building in a number of safeguards now, proactively into your scooters, to ensure that you get, a sort of an early warning before, the battery just sort of combusts. The question is that with EVs running on the roads right now, and again, you address this, that what can we sort of do to improve, and ensure that whatever we have on the roads, again, is running robustly and safely. If you could speak to, perhaps from an SMEV perspective, which is an alliance of, EV manufacturers coming together. What are your takeaways from the recent instances that we have seen? Right, I mean, it's easily put away to the conditions in India, whether it's heat or road vibrations. Are there fundamental issues also that that this reveals, and that perhaps upstarts also need to carefully evaluate and take on board going forward? So you're on mute, I'm afraid.
Yeah, so much has been said by experts, and I fully am in consonance with what Randheer is saying, that policy has done whatever it could do, and certification can do what it can. So it is not a police standing for every battery that you're making. So they are doing the job. Now it comes to OEMs to do what the rest of it is. And just copying any technology from abroad will not work in India. Everybody is saying that. We have our own problems. We have to find our own solutions. We have to be much more safer than the other batteries around the world, which means a huge learning ahead. We should have done it in the past, but at least, we should immediately take up all the things that are being talked of cell spacings, better BMSs and everything. But it'll lead to something like 6 months later, something which is much better than today. So also there's another angle to it. Perhaps I don't know whether it was covered because I joined late. Another
Yeah.
problem is that batteries, even if the cell is okay from day one, after 2 or 3 years, it can become explosive because of deterioration. So the batteries which are certified or inspected okay, if they are not working well, not charged properly, or not handled properly, can become dangerous after a few years. Now, this is the life cycle of a battery, which is 5 years, 7 years, 8 years. So, unless the OEMs and the battery makers are able to run it through that life cycle and understand the mass
Yeah.
behavior of millions of the batteries, they will not be able to superimpose the new batteries behavior on top of them to say that some of these batteries went this way, that is why they will end up dangerously. So I'm saying benchmarking of batteries here. Now that cannot be, you can't wait for 7 years for to introduce a product, but you can simulate the same conditions in 2 or 3 years of the complete end of life behavior of all the batteries in big numbers. Once you do it,
Right.
you have a very good database that, okay, in 6 months, such batteries started misbehaving and they became explosive. So within 6 months, you knew the new set of batteries will misbehave. So better take them out or do something about it. So this is missing from Indian automotive scene here in EVs. The hurry to market products, the hurry to
Hmm.
launch products without going through
Hmm.
this 3, 4, 5 years of learning, or at least 2 years of simulation, is one of the key reasons of the best of the designs, or perhaps best of the intentions, still leading to some of the behaviors which are out of trend of the benchmark batteries, and they don't know then what to do with it. So in future, I would believe, in addition to the technology improving, designs improving, chemistry surely changing to safer chemistries, which everybody would have talked, we also need to see to it that we have data with us for quite a number of batteries, thousands of batteries, to be able to have a clear distinction between a bad behavior over life and a good behavior over life, leading to segregation, leading to some sort of a correction, leading to redesign of BMSs, etc. As far as customer education is concerned, it is so very important here. We
Hmm.
have been educating customer all these 10 years, 14 years. Please don't come back from riding 60 kilometers in the sun and start charging your battery. Although our
Yeah.
charger stops it, but still it boils the battery there. So customer education of frequently himself knowing the telltale
Hmm.
signs of the battery once in 2, 3 months, bringing it to service stations so that some bulge can be noticed, some abnormality can be noticed, some color changes can be noticed is so very important. Charging correctly at a cool point or with proper charging is so. Another aspect is that customer is not accountable for it, but let's make him aware about these things is
Sure.
also going to add to the safety factor.
Right. Um, Suhas, I want to come back to you and request you to respond to some of the things Mr. Gill mentioned. You did say that you have taken the time to really develop your product and you're launching it in a few months from now. Have you been able to actually test the batteries that you'd be using for that 2 to 3 year cycle? And then going forward, because there is so much interest in the product that you're going to launch, there will be heightened customer expectations also, and you will have to proactively assuage concerns that customers will start to have, right? Because you're
Yeah.
launching after these incidents have happened. How do you address all of these things together? Some part about the customer education also, a function of this will also have to be service, right? So that customers know where to turn to if they notice these signs. How are you solving for all of that?
Before that, this incident doesn't change anything for us because again, some changes cannot be done overnight. They take some time. So we've been doing that from day one. Coming back to showcasing ourselves, I think we are planning to showcase, as Arun mentioned. We test internally and we videograph all the tests that a battery pack on individual level goes through or a component level goes through. We'll put it out. Commanding what kind of quality checks that we have done and what the product has been offering will be offering. So having said that, again, to understand the basics of it, cell level, battery level, vehicle level. So there are 3 different layers to understand, and of course, thermal runaways cannot be controlled. Every single time there'll be one case in million. But how can you avoid thermal runaways? Something that people need to focus on, right? You cannot control every part of it. You'll have to make sure that 99% of times that doesn't happen, and that can be done only by extensive R&D on the kind of materials you'll put along with the cell there. Be it your fuse boards, be it your BMSs, be it your PCM materials, be it your pressure valves. Battery packaging also can be stimulated with a pressure valve, knowing and understanding what is the highest of the temperatures the battery packs can release, or what are the gases that can accumulate, and how can you start working around it and place certain things rightly in the battery pack, so you don't really have to worry about dimension or a packaging or any kind of other aspects of the battery packs. Neither the consumer has to really go to and fro and carry a check card with him, understanding how things, because for a consumer it is about quality, and for OEM it has to be primary focus. So we are here to solve everything, and our name suggests simple, so we want to make everything as simple as possible for a consumer. Coming back to how can a consumer detect, so we have inbuilt our apps saying this, mandatory checks every 3 months or 4 months. You'll have a notification coming on your apps saying that your scooter needs a regular checkup. It'll be free of cost for initial few months or a year maybe, where we can ensure just not the safety of the scooter, but also whole sessions that we can educate customers how have been they using the scooter, and give them data points after 3 months or 4 months or 6 months of usage of the vehicle, and help them understand how the scooter is behaving, and give them
I want to intervene for a second here, Suhas, and ask you: are any of your peers doing this already? What you mentioned about mandatory sort of 3 month or like a quarterly sort of a check, to ensure your scooter is doing fine.
I'm not really aware of our peers, but it should be done on a company level. See, policies can be mandated, everything is there, but as a company, your focus or ethos should be customer focus, and try to integrate as much as you can. Today's digital world, you can notify your consumer every now and then, remind them, instead of reminding of an ad, you can just send them a reminder of their just the way we send health checkup for ourselves. We can just, why not just help them understand the EV is a nascent state. So 3-4 years, people take some time to understand them, and once they understood, everything's going to be smooth and much more evolved going forward.
Interesting. Arun, I want to give you the last word here, and maybe you can come in a little bit from the Ather perspective also. You did say, and again, Ather fortunately has not seen an incident of a fire so far. That perhaps could also be, in part due to the fact that the company did take some time to expand, right? And, there was an earlier iteration of a product, and then a new one came, with improvements. Do you think that will also have to be the way that the industry sort of works and evolves, just to sort of pace things out a little bit, as far as the product is also concerned, and then take on board the feedback that the market also gives you, and incorporate that into the product as you go along?
Absolutely, Alisha. I don't think there's any other option. This is not software. This is not building apps. We're not trying to deliver a samosa in 15 minutes. You're building very high-tech, complicated products that need deep integration. Expertise needs to come first, and then capital. Unfortunately, today, or fortunately, it's good. Like, capital comes, and then expertise is sort of loosely put together. And
that's the debate of the day, honestly.
Yeah.
Capital cannot get you things.
Software, break fast, let's move fast, break things, whatever, right? Like you can't do that in hardware, or at least you got to move fast and break things in your lab, and you've got to iterate enough times, blow things up in your lab to ensure things don't blow up in the field. It's a very different culture, very different DNA, and honestly, in India, it's not being great at building products, right? Even in our legacy automotive OEMs, and a lot of them hate me for saying this, we've always been given platforms, right, from abroad. Like, when is the last time we built a platform from scratch in India, right? Very, very recently. A lot of respect for Tata and the Mahindras who've been doing this for the last 10 years in India. But that's been in diesel, which is a pretty, I would say, stabilized category. You have technology providers around the world. You can call up and say, give me an injector, give me tires, give me wheels, give me axles, and all come together, right? None of this exists in EV. So you've got to go back 100 years, build vehicles ground up, or you build technology ground up, but you got to do it in 2022 with the capital that's chasing you and the demand that's chasing you. So there's no easy decision, and so I can only empathize for myself, for the other founders in this space, and everyone else running an EV company today. But there's no easy decision. But definitely the right decision is ensure you've tested your products enough and chase product quality, because I'm a deep believer that there's democracy in consumers paying for product. Saying, I will pay for better product, better safety.
Right. On the point of democracy also, Arun, the solution that you are building, caters to a wide range of battery chemistries also, right? So that's one question I want to, get you to address, and maybe, get Mr. Gill to add on to. Is there a kind of battery, that is safer than the other, that, should perhaps be mandated or be preferred, over another kind of battery? That can also, significantly, let's say, solve this issue or make vehicles safer?
Well, as an engineer, I would say no, but if I were to look at this as from prioritization perspective, yes. If I look at something like LFP with lithium iron phosphate generally runs at a lower energy density, and it's you really have to try hard to blow them up. Right? They're much safer than something like NMC, which is far more sensitive, right? But it's not like NMC is bad. It just needs a little different sort of engineering around it. So that's why, as an engineer, I think they're both great. They both have importance for different categories. But I think in India, as you look at delivery vehicles, cargo vehicles, it's a no-brainer. LFP is definitely the way to go. Also, from an India manufacturing point of view, localized cell manufacturing point of view, LFP is definitely the way to go, because it does not need manganese and cobalt, which are very hard to manage supply chain for. So big believer in LFP. That coincidentally solves the safety problem, but of course that's not the reason why we should do it. You can have safe NMC batteries as well.
Got it. Mr. Gill, okay, the last word to you now, really, if you want to build on, what Arun said about, whether there is a safe battery really, and how safe can you actually make batteries of all kinds of chemistries?
Well, Arun said that, and that's right. Like any current chemistry can be made safer, but you need much more efforts to make some of the chemistries safer than you would need for an LFP. To err on the safer side, I would advocate for the time being, till the time we resolve these issues, performance should be sacrificed, safety should be taken on priority. So guys who have not been able to design their batteries well should convert to safer chemistries, so that at least they don't explode as a bomb, they only smolder. Second part is, we are certifying the battery as a finished product today. Perhaps in the design, nobody is entering into it. It's left to OEMs' choice of cell spacing, cell type of BMS. Perhaps we can work out with the policy makers to certification agencies also mandating a minimum safety standards within the battery as far as BMSs are concerned, as far as thermal runaway controls are concerned, so that not only the complete battery is tested, those sub-components are also tested for being mandatorily present within a battery, so that one rare or stray incident is also not happening, and there are checks and balances which are in place. So let it not be a domain of a manufacturer. Whatever you want to produce, we'll just certify by checking for 4 hours, 6 hours, and say you can go ahead and put these millions of batteries. Let us go into a next level and a next level to see that these things must be present within a battery. And then only we will pass it or we will certify it.
Alisha, you might add to that. I'm not sure if you have time, but
sure.
Just quickly, I think it's very easy to start looking at legislation and standardization, right? But that's a two-sided sword, because that then kills innovation, right? You're not going to have differentiation. You're not going to have quick innovation. And it's very easy to say this is EVs, it's unsafe, it's a startup. But every industry has gone through this problem. If you look at IC engine vehicles, there was a time when you're
going back to the 1900s, yes.
Yeah, or actually not that far away, like in late 90s, right? When you had your throttle pedal was actually mechanically connected to your engine, and then at some point in time we said, hey, let's drive by wire. So your throttle is actually electronic, and you have a very different system, right? And this was a large legacy player, right? And they had the first drive-by-wire system, and suddenly you would have vehicles accidentally accelerating, and you could say, hey, this was a legacy player, how come they got quality wrong? And there was a large recall, there was a lot of safety, and a few lives lost as well, right? So I'm not saying that was right, I'm not saying this is right, but I'm saying every industry as you see in innovation, may it be a startup or a legacy player, there are failures. And the way legislation comes, and for that there was an ISO 26262 standard that came up and created that standard. And the beauty of the standard is it enforces safety without killing innovation. And I think that's a sort of standard that we need in India.
Yeah. I would also
Right.
like to add something here, just to
Go
continue.
ahead.
Yeah.
Go ahead.
So again, as the thing was about chemistries and safety, which is a safer chemistry, I think there is nothing like that. It is more to do with how an OEM chooses for what purpose. A B2B can have a different chemistry, or a performance vehicle can have a different chemistry. Performance safety also can go together. It's all about R&D. It's all about core ethos a brand carries, and safety standards are important rather than battery standards. That is the paramount thing that any policymaker should focus on. And that can give you, and startups have shown the way for things from 150 years. Ford also a startup eventually became a OEM, but that's again a start of innovation, and innovation can continue in this industry. Better cathode chemistries can come over, better cell chemistries might be coming over, better backs can be thought about and studied upon and built upon by OEMs themselves by taking examples. So that's my take on how chemistries or how battery packs can be safer. It's all about core ethos a company should work on.
Fair enough. It's been lovely to, be able to absorb all of this valuable insight that all of you have shared, gentlemen. So thank you once again for taking your time out and, enriching me and the audience really with all of those insights. Like everyone correctly said, it is a new technology. It will take its time. There will be a gestation period before it sort of becomes perfect. But the effort in the meantime, I believe for everyone is to ensure that there is, that we minimize the damage as much as we can. Look forward, to continuing this conversation, another time as well. But for now, thank you so much for joining us.
Thank you.
On Mint.
Thank you.
Thank you.
Thank you so
Thank
much.
you.
Thank you.